Hello everyone, welcome back to Alex Aerolab. Today we'll be going a quick update on the wing modeling study. So you might have remembered in my previous video I was discussing some of the boundary layer mesh issues I was having around the surface of my wing. I was using Snappy Hex Mesh, which is the built-in meshing software in OpenFOAM, and it's very sensitive to the quality parameters within its control dictionary, as well as it's just a different type of mesh layering algorithm than what I was used to, say, from using like ANSYS Fluent. So you might have remembered in that previous video, I mentioned I was going to look into some new meshing software. I began by looking at a program called CF Mesh. This is another open source meshing program. It comes with certain versions of OpenFOAM. It's that sub-layer, boundary layer meshing algorithm that just isn't what I was looking for. It's like, why learn the new thing when I already have that with Snappy Hex Mesh? I looked at another software called Gmesh, which is a really cool open source software. It does a lot of unstructured meshing, but doesn't really have a convenient way to do 3D boundary layer meshing at this point in time. I'm sure there's a way that you could force it, but I just wasn't looking to put that much time into learning a totally new software where it might not work well. Or at least before I did that, I wanted to make sure that I really had exceeded the limit on what I could do with Snappy Hex Mesh. So I decided to bite the bullet, go back into it and start from scratch and see if I could improve the mesh. When I created that original mesh that I tested for this project, one of the tips I picked up on for creating a good boundary layer mesh on that surface was you want to have really fine resolution on that surface. And so my first step in creating this new mesh from scratch was to just cut that initial mesh resolution in half. So I had even more there to see if I could get more boundary layers to grow of higher quality cells. And sure enough, I did. I got way nicer looking cells and I was able to add way more. I also sort of fiddled around with some of the refinement zones within the mesh. I wanted to have more refinement behind the wing. I wanted to be able to really make sure I was capturing those trailing vortices better. I just went ahead and tested this new mesh, and wow, did it give me better results. I was really excited. I got within 10% of the experimental values on the lift coefficient, and I was just buzzing. I was so excited that I actually made a mistake. I immediately rushed into just running another resolution study test without really seeing how the number of layers in that boundary zone was affecting not only the results, but the quality of the mesh. Now, the goal of this resolution test was really to just prove that this base mesh I designed was already giving me mesh independent values. So I created some smaller initial base cell size level meshes and refined them down to this cell size I had been testing with. And as I was going along, sure enough, it was slowly converging. I was like, this is looking great. And then at that level right before this base mesh I had, all of a sudden the value just spiked. It just totally went haywire. And I was like, oh crap, I messed up. At the time, I didn't know what this mistake was from. Is it from, say, the quality of the mesh? Is it because of the number of layers in the boundary layer? I just didn't know. I didn't test to see if the number of layers I was using in each boundary layer for each level of resolution was giving me converged results. Like, is the fact that I was running them with 16 layers different than if I had run them with 20? I just don't know. So I decided I needed to run a new resolution study. That's the theme of this channel. Just to see if the number of layers was the reason why this mesh was acting so strangely. So I did that. I ran the 4 levels of refinement again, and within each I ran 3 different levels of number of layers in the wing. And that took about a week. And as I just found out, they were giving me converged results for that level. So the fact that I was running with the level of cell layers that was fine. However, it is the mesh quality once again causing us issues. So the first thing I did was I checked the Y+ values on the wing. The suction side was great now, much less than 1. The one spot where things were not looking so hot was that intersection between the wing and the end plate. Those sharp right angles were very much a problematic zone, and that makes sense. Snappy hex mesh is just calculating the boundary layer cell thickness, displacing that original mesh, and then inserting those new layers. When you do that on a side and the bottom surface, that right angle, it's going to create something funky. So to see what impact this funky region is having on the results, I'm running a new series of simulations. I'm decreasing the number of boundary layer cells on the end plate to really low values, to even none, just to see if I can create a nicer region there. I know F1 teams will do a mixed Y+ approach to their simulations, where they're just trying to get that really low one, like less than 5, one region on lifting surfaces, on airfoils, and then to save on computational power, they're doing higher Y+ values on non-lifting surfaces and other parts of the car. I would consider the end plate to be part of a lifting surface on the car, but we're working with open source meshing here, so if we can get a nicer quality mesh and it gives better, at least consistent results across a variety of refinement designs, I'll take it. So we're running with that right now. We're gonna see how that turns out in a few days. Now, also in my previous video, I mentioned I was gonna be doing an airfoil design project in tandem with this one. And as I was starting it, I realized there were some unknown unknowns I didn't know I had. And it prompted me to do a rather extensive lit review on wings and ground effect, as well as just some high lift airfoil aerodynamic stuff. So I'm working on that at the moment. It's a pretty extensive lit review. It's going to be about 75 papers going into this thing. It's going to be broken up into a few subsections. And as I'm doing this lit review, I intend on putting out some longer form videos that go over some of the cool physics that I'm learning along the way. So expect that in the next few weeks. But until I have that done, I'm holding off on the airfoil project because, again, I want to be putting out high quality engineering, not just showing you cool stuff that, oh, I threw this CAD geometry in and look at the results. No, we're doing real design work here. We're doing real engineering. So stay tuned. I'll see you next week. Thanks for watching.